Thanks a ton. Once again, my name is Kyle Forster, one of the founders of Big Switch. Let's talk for a little bit about monitoring fabrics. I'll go into some context because I think it's worth talking about where a monitoring fabric sits in a network. For this audience, I think most people are going to sort of nod and say, I get it, but it's worth going through it. But more importantly, before I do that, why are monitoring fabrics really important? A whole bunch of us were at SDDC on Tuesday. I don't know if you heard, but Andy Brown made one comment while he was up on the panel that I thought was really, kind of sums it up. He said, look, if I'm going to start playing with SDN and I'm going to start playing with bare metal, my first step isn't going to be smack in the middle of my mission critical data center. My first step is going to be right alongside. I'm going to use that to get up to speed, and then I'm going to go smack in the middle of the data center. So monitoring fabrics are kind of the perfect first place to start. It's the stepping stone into SDN, it's the stepping stone into bare metal. We'll come back to this. All right, what is a monitoring fabric and where do we start? Well, if we look 10 years ago, the standard, and certainly in any smaller company, right, in a smaller data center, the standard is going to be you have a set of taps or span ports, and you have a set of tools connected to them, and they're directly connected. This is where everybody starts. Well, over the last 10 years, the tools industry has effectively exploded. I mean, about a factor of 5 in the last 8 years alone. So this has given rise to this idea that you're going to have a handful of tools that are all actually competing for the same set of tap and span ports. This has given rise to the set of products that we collectively call network packet brokers. Network packet brokers both do L1 matrix switching, do a little bit of filtering, but also have a long tail of other features that they're pulling out of the tools. Well, let's talk about monitoring fabrics. Going forward, to give you a sense, we're actually tracking 300 different potential tool partners that all play some role in offline analysis. It's a huge amount. Network performance analysis, application performance analysis, a huge plethora and a growing plethora of security tools. And for large networks, you wind up with more and more of these. You wind up with more and more teams that now own not only their own tool, but that are participating in these larger and larger tool farms. And so what we're doing with monitoring fabrics is you're seeing across the industry, folks start putting in this idea of an entire fabric that actually sits in between the production network and all the tools. So here's the space where monitoring fabrics play. They're fundamentally offline. They forward packets very differently from a traditional network because they're not actually looking at the L2 or the L3 headers. Right? You're forwarding based on very different parameters. So it's actually an interesting and a hard problem for traditional networking gear to get there. I'll talk about 3 different areas that we think are particularly interesting, designs that we're actively working on right now with large customers. And as you look at these 3, I want you to look at 3 things. First, I want you to see that these folks are doing this because it's the first step towards SDN and towards bare metal. The second reason is that the fact is because it's on bare metal, the price points that we're able to achieve are opening up a lot of latent demand. There are a whole series of use cases that were just unachievable because the prices were so far out of whack. But we can show, hey, now these can be done. The third thing that I want you to look at as we go through these is just, I think one thing that the team here has done very, very well is insert the entire idea of multi-tenancy. You see this very strongly across all of our product lines and what multi-tenant operations means. And we're going to dive into a demo in about 2 seconds where I'll show you exactly what this looks like to operate. If we look at how people are using it, so we have a large Web 2.0 data center. The design they're working on, they have 3 teams that all need to share the same set of taps. It seems like a simple problem at first, but the nightmare is everybody needs to share the same taps at the same time, and you might have a specific subnet that you're looking at, but I want to see all the ICMP traffic. So sharing the tap and sharing tools, sharing sort of the NPVs in the middle is actually extraordinarily difficult. We'll talk about that in a minute. We're working with a mobile carrier, and what they're doing, they're actually converging the entire infrastructure that they use for service assurance with the infrastructure that they're using for lawful intercept. So this is one of these mega scale projects But the gist is that they have all of these tools that fundamentally need the same set of traffic. They need the S1, they need the S11, they need the S43 off of the PGW, off of the SGW, and at some point off the eNode Bs direct. So this is a pretty exciting area where they're actually converging very different parts of their own business, very different parts of their own offline network, all into one. And the third is actually near and dear to my heart because I started my career as a software developer building large back-end software systems for banks. And this was actually a continuous problem. This is a financial services firm slash software company. They're both. They're actually building, they're using our GUI to build a self-service portal so that when an application sees performance problems and the escalation starts, and you get into that finger pointing between the networking team and the software team, you say, no, it's your software that's slow, no, it's the network that's slow. Instead of what I had to do through the 90s was open a trouble ticket, wait a week, get my production PCAP file back, analyze it, make a guess at what was wrong, open another ticket, wait another week. Instead, they're doing this whole thing in self-service. So no more trouble tickets. The software developers are actually using the GUI to self-service get their own PCAP file straight from the production network. And if they want to run 5 different analyses in an hour, great, no problem. This is the same thing that used to take me 2 months. Demo. So the demo setup, we're just going to show a mini fabric. All right, we're going to show 2 switches. We're going to show three what we call filter ports, right? 2 taps and span ports that are connected to this set of switches. And we're going to show 3 tools that are associated with them. Now, we'll do a little CLI walkthrough. And the first step, I'm going to configure the switches. There is no configuration on the switches. None. The only thing the switches have is the IP address of the controller. That's it. That's all. All the CLI you're going to see is actually sitting on the controller itself. We'll walk through that a bit. I'll point out some of the interesting areas, then we'll walk through the GUI and we'll see, hey, here's how a security team and a NetOps team would use this thing in parallel.
So who was saying something about config files like half an hour ago? Who was saying something about config files half an hour ago?
Well, config files, that's a different story. Actually, it's kind of a half joke because our CLI is actually a small program that's built on top of our REST APIs. So what you're actually seeing right now, everything that you see right now is going to go back and forth via our REST APIs to the controller. So we're going to simulate the config file.
This is a configuration database in a REST API. We're trying really hard to make it look like a CLI. So it's very easy.
So that's what I was looking at. Can everybody see this, by the way, or is this a little too small?
A little small.
Too small?
Yeah. Come on, plus. Perfect. That's better.
Perfect.
All right. So first up, there's some setup of just users. Users, groups, and views. I mean, this is the fundamentals of any kind of multi-tenant system, so we just have to do it. Set up with some controller nodes. Here's all the setup that we're going to do with the switches. Notice we're not saying anything about the topology. All that's going to be learned. What we are doing is we're saying, giving names to specific interfaces at the edge of the fabric. So the edge of the fabric that faces our taps, we call them filter, right? Filter ports. So our filter interfaces, we'll name those. And our delivery interfaces, we'll name those. Now, the beautiful thing about the way that the NPB industry has evolved is they have this long tail of features, things, timestamping in all kinds of different ways, payload stripping in all kinds of different ways, and 100 of those. Instead of trying to replicate those, we actually have this model where you can attach an NPV to the Big Tap fabric, and we call them service ports. You want timestamping? We have a timestamping in, we have a timestamping out, and you can actually use the long tail features of these boxes that most people already have one or two of them around. The issue is they just don't have enough ports. So this is all the setup on the switches. And here's kind of the meat of the operational aspects this thing. Right. We're going to show 3 policies. 2 of them are for network operations, and 1 of them is being run by security operations.
Now, I get the delivery interface. What's the filter interface? That's the inbound?
That's the inbound.
Okay. And this interfaces have, they don't have to be on the same switch, right?
Nope.
Oh, that's cool.
There could be a 30-switch fabric
that's
sitting
fine.
here.
So you build a virtual circuit.
Exactly. Now,
just out of curiosity, do you install the full flow tuples in all intermediate switches, or do you actually build a virtual circuit and only have a full flow tuple in the first switch?
better.
Good.
We do, I think, a couple steps better. So V1 as a prototype, we actually set up full circuits. Yeah. But what we found is, the old model of using these things is a little bit like setting firewall rules. You set one filter, you're going to break everything below you. And so you have one person who really, really, really knows the ACL list. But what we're really striving for, actually, to be very honest, what our first couple of customers were really pushing us for was this idea of true multi-tenancy. So every tenant can be firing in policies at any time. Because look closely, right? Check out filter 4. At the same time, we want to get all ICMP traffic on filter 4, and we want to get that out to the IDS. But we're going to grab everything from 10.0.0.12, and we're going to send that over to Wireshark. Or we construct on top of these more and more overlapping policies. And in fact, we want to even twiddle it a little more. We want to take anything that comes out of this particular filter, right, this particular policy, and we want to rewrite VLAN 10 just to, let's say we have a handful of policies all go into the same tool and we want to disambiguate by VLAN number. But this is going to intermix. It's going to be riding on the exact same filter as the earlier. Rather than setting up a virtual circuit, we did that in the prototype days. When we GA'd, we're actually managing a data structure underneath. Think about it like a huge Venn diagram of all the policies. So the policies, rather than going to flow mods direct, the policies go into a data structure. We then say, hey, look, here's overlapping policies. Here's where we're going to replicate packets. Here's separate. Here's where we're actually going to take separate paths, and we're going to make sure they always get sent to the same tool. There's a fair amount of optimization that rolls on top because you face an exponential explosion problem. But it's pretty slick. It's actually a hard set of problems to solve underneath. But when we solve those problems in software, the user doesn't have to solve them. The SecOps team and the NetOps team can be firing policies anytime they want onto the exact same tap, and they never need to know that the other guy exists. I mean, that was the purpose of solving the thing in software.
And you get the pushback from the physical switch if you exceed the TCAM limit, right?
Say again?
You get the pushback from the physical switch if you exceed the TCAM limit. So if someone tries to instantiate a policy and the TCAM is full, you go like, oops, sorry.
Yeah, that's absolutely the case. And the other side of it, which you were kind of hinting at, which is, do we have the exact match every way through there? The answer is currently yes, but there's a lot of room for optimization. And so one can imagine the limit of the system in terms of policies is not the limit of the smallest TCAM.
Well, it's key value in CAM, right? Binary.
Yeah.
So when you push to, because a limitation traditionally in at least the Trident Plus was you couldn't do a destination L2 rewrite. So I can't go to now a clustered IDS. Are you guys able to distribute that out?
Cough. NDA, cough.
Got it.
Just going to ride you through a little bit of the GUI, right? We have a sense of obviously configured state. as well as operational states that can tell us, hey, here's exactly what's happening with this particular policy. Just be able to track it all the way through from your filter interfaces all the way through what we call the core. That's anything in the middle of the fabric, all the way out to delivery. And importantly here, you see, all right, I'm looking at NetOps. If I re-log in as SecOps, all I get to see are actually my policies. And we can show the full set of RBAC that we can do here is you can split out, okay, some people own 100% of certain taps, some people own 100% of certain IP space. We can actually
It's really important because security doesn't, so if security's doing tapping of some sort, they don't want the networking people to necessarily know that they need to be able to tap without, a lot of companies actually have multiple tap fabrics, one for security, one for networking, and one for dev.
Yeah.
And this allows you to split it up into one fabric. So it is multi-tenant in that sense, yeah.
And they can all, the thing that we find the most popular is everybody can make changes without any central coordination.
Yes.
The security team wants to make a change, great, go for it.
Yeah.
The real popular place has been NetOps, so that NetOps can share with all kinds of different security teams, because the security taps and filters tend to be fairly long-lived. But if you have a NetOps team that's coming in to troubleshoot something very specific, they're going to be in and out in a few hours.
Yeah.
You know, no more of this, oh, hey, can we afford an hour of downtime across this set of IDSs because we desperately, really need this particular tap point. Mm-hmm. Right? Like everybody can share the same physical infrastructure underneath.
And when you did the drop down there, you actually showed each hop of the tap path across the fabric, right? So you're actually then able to see what's the performance of each hop. So you could then make sure that you're actually capturing all the packets, because if you're tapping, it's absolutely vital that you don't drop anything. You can't lose any data effectively in that pathway.
One thing that we certainly found out very early was that the ability to debug the monitoring network is the single most important feature set that you can deliver very well and cleanly. And so making sure that was instrumented well was a very big deal. Because the first thing, whenever anybody sees a PCAP that they don't totally understand, the first thing, oh, are we sure the monitoring network did what we intended it to do? So proving the monitoring network was solid was just a really important first step.
Yeah.
Hey, Kyle, so you kind of touched on the logical place to start because of any potential disruption is kind of in parallel.
Yeah.
So what we're doing, where I'm at is because at some point we kind of integrate the two, and building out separate physical networks gets a little crazy. So what we're doing is just open flow normal, and then it's just like selective flow peeling, however you want it. I assume you guys support that. You have any thoughts on that? And then I'd love to hear your kind of take on how do you integrate into the native network. I think that's one of the harder parts for traditional networking to kind of.
So with this, today we integrate with the native network simply with the tap point, the physical tap or the span port itself is a demarc point. For a lot of the folks that we've traditionally dealt with, that's the comfortable place to be today. There's a lot more to come there because there's some pretty exciting areas when we can reach into the production network itself and use production network actually as the filter switches. Even production V switches as the filter switches, but that's to come. Cool. Step one is to make this very trusted. And it's a nice way to make it trusted because it's the folks it's the ops team and it's the escalation teams that are doing the debugging, and this is the tool for them. So number one, right, it helps get them trusted there. So there's a personality thing. Mm-hmm. The monitoring networks themselves have to be so easily debuggable because that's always where everybody looks first. Hey, I don't understand what's in this PCAP file. It must be the fault of the monitoring network, right? That's always the first step. So a lot of other things have to be in place before somebody really starts to trust this. I think the team here has actually done a very good job of that.
So something I struggle with is the network-centric approach to SDN is just tough. I think it's significantly longer than a software approach. So how do you, it's because there's kind of this whole education and that's a tall order. How do we get around that? How do you see that happening?
I think we accept it. The networking-centric approach to SDN is going to take longer, and it's worth it. It's more impactful. The products that we can build are better, and we think they'll have a lot more impact on how data centers are run. I think we accept it and we say it's absolutely the right thing to do.
Yeah, I think ultimately the way we see software-defined networking today with this, you implemented it software at the edge of the network, is just a transitionary phase. It's something we're going to go through. We're going to work out what we need and how we want it, and then eventually we'll actually take the SDN that we've got working on software agents and apply it to the physical network as well, because having the hardware has to evolve. There has to be a change in the the industry skilling and experience, but carving your tunnel, I call it carving. Carving your flows across the network is my own term in my mind, but carving the flows through the network itself makes sense. Why would you just tunnel everything across the network? At some point, it's going to be more efficient to actually carve out a channel through the physical network and do it that way and do it direct. In the same way that we started off with SNA as an overlay, and then it went native, and then it went back to being an overlay. This industry is going to go backwards and forwards between different technologies, so don't get too... I keep trying to tell myself don't get too fixated on any particular way, because it's going to keep changing for the next decade before it gets dull and boring again.
And I think that's one of the interesting things about this decoupled operating system. I mean, it's like kind of a no-brainer when you really start thinking about it. It's like, oh, computing's been doing that for a long time. Why have we been reluctant to do that?
Because, the answer has always been because network processors are different to CPUs. There's never been a universal use case for a network, and that the real-time operating system, I'm going to come back on this again, those nanosecond gaps, the millisecond gaps, you don't get the freedom like you do on an Intel platform, which is running Linux, and if you get it wrong, it just runs slower, right? In networking, the silicon architectures are so, TCAMs are expensive and hard, and they have to be timed, and that. So I think we've had the integrated model because it made sense, but that doesn't mean it always has to be integrated.
Well, we've heard NDA quite a bit here. I mean, look at the battle between Torvald and NVIDIA, right? The third-party driver. I mean, that's going to be a big problem from the ODMs, right? The chip manufacturers. If this is always closed and you're only allowed to use it on your OS if they let you use it on their OS and give you primitives, is that?
To comment that quickly, it's not that bad, and it's getting better, right? So, for example, back at Stanford, we did have access to these SDKs. So, if you sign the NDA with the switch manufacturer, the silicon manufacturer, right, they will give you access to the software, and then we're happy to ship you that source code as well. Does that make sense?
Yeah, absolutely. Cool.
I mean, there's quite a number of people out there that at this point are just doing development directly on the switches.
Yeah, the NDAs are a problem. Intel doesn't hide too much about its x86 processor, so I'm stumped as to why Broadcom and Intel are hiding all this detail about their network cores. It's baffling.
We'll see. I hope at some point they'll just open it up this way it is for CPUs today. Right?
Yeah. So if you want to have a look at what's under the hood of your car, you open the hood and you can take it apart and look at it, right? Yeah. And you can get all the specs up front before you buy it. But if I want to look at the silicon that's inside the Trident 2 chipset, I can't. I'm not allowed to know. Anyway.
If I can quickly jump in, my claim is that will happen.
Yes.
What time frame it happens, we'll see. There are a lot of people who are interested in making that happen, even in those companies. So we'll see.
Yeah.
Question actually on Big Tap. Can you go back to the diagram slide real quick? It'll be easier to ask the question. You have those two switches, those 4 links between the switches. Mm-hmm. How are you distributing traffic over those 4 links? And if you exceed 10 gig on one link, do you have overflow to the other 3, or if one fails, how does that? Is it a single logical interface, or do you view it as 4 independent? Just trying to
think about it. That whenever we recalculate the Venn diagram underneath, you sort of need to relay that out physically. So you recalculate the Venn diagram, you figure out the diffs between that and the flow table in your switches, and then you make the edits.
Right. So let's say
you actually do use all 4 links in parallel.
Right. So if one link is at 9.5, 10 gig, is it smart enough to know to put the next thing you want to span or mirror onto the other 3?
Yeah. I mean, today we do sort of simple round robin across the links.
Okay.
Because that's easier than trying to predict what the future monitoring traffic is going to be based on past. We are looking at other ways to do it. They're sort of straightforward. They just create more and more engineering work for the tenants of the monitoring fabric. So the trick is, how do you wrap them up so you don't need to be an expert in the monitoring fabric in order to get the security ops job done, or in order to get the PCAP file that you need to Wireshark. Okay. Where we can, we make the trade-offs to get to that simplicity, so that it's people who are ideally not even native networking pros they can get their own PCAP files out, or they can get their own IDS tool hooked up very, very rapidly.
I was just curious if you were bundling them, viewing it as one logical, or viewing it as four physical. That makes sense.
Yeah, 4 physical.
Okay.
So the deployment scenario here would be that you use separate monitoring network where you would use your or whoever's OpenFlow switches and control those. So you wouldn't touch the actual physical switches in the physical network.
Exactly.
Okay, now it makes sense.
Exactly.
Right. It's actually really nice for customers, right? Because they may not fully trust us yet on the main network.
Yeah, sure.
But this is a great way to get started, right?
So like one thing that we've been knocking around is, because it's kind of, it's a kind of a pain to map flows all the way, to do the flow stitching all the way through.
Manually? Oh, yeah.
Right. So actually nailing up a tunnel between, let's say you just have one pile of compute that's going to collect all this data sitting centrally in a campus or wherever else. We're actually looking at just doing tunnels to kind of abstract the rest. So wiring closets will just build a tunnel to some central point, and that's just, so now I just worry about one action. I don't worry about state upstream and all that. Is your box, long story short, is the box tunnel aware?
We're looking at all kinds of use cases to work tunnels in, as the appropriate support is there in the ASICs. Because obviously, we have a long legacy on the controller side of being able to manage tunnels, and I think we do it very, very well.
Right.
But figuring out how to intermingle those in ways that, again, are both practical and very, very easy to use, that's the trick. So we'll get there.
Now, another one. Since you installed the full flow mods on all the switches in the path, how do you handle overlapping addresses?
This is what Kyle got to earlier. Sorry.
No, go for it.
We actually compute the Venn diagram. And so if there's an overlap, we actually insert, for example, the trivial overlap, we insert 3 rules. One for what matches only policy 1 only matches policy 2, and one that matches both. And the actions that matches both actually duplicates the packet.
That's not the problem. The problem is that I have 2 tenants, and they both have network 10. Or I have network 10 outside, and then I have a load balancer, and this is a new routing domain, and I have a network 10 inside. And I have the same address. And they both want to monitor network 10, but I don't want them to see the other network 10 traffic.
So, fundamentally, you have solved this problem on your network somehow with VLAN tags, with MPLS tags, or physically isolating the port. And we can do exactly the same thing, which is to say, somewhere in your network, there's some demarc. And whether that's a physical port isolation, network 10 only comes off of this tap, and the other network 10 only comes off of this other tap, we can replicate that. But you have already solved this problem. We just need to write on your solution.
Well, are you asking how we're differentiating once it's inside our fabric? Right?
Yeah.
We just add a tag or something like that as differentiator. We know what kind of traffic is happening, right? So we can basically just...
We match on the input ports, right?
Yeah, you match on port.
Anyways, go on.
Yeah. But if you have
Okay,
to,
I got
get
the
over
message.
same link, then...
If I don't mark, well, too bad. You solve your problem first. Fair?
We solve that problem for you, right? We use some... we reserve the right to modify packets internally, but you won't see it. Right?